Hey everyone, and welcome to Kongcast. I'm Kaitlyn Barnard, and in this series, we chat with software developers and technology leaders to tackle your biggest connectivity challenges. Today, I'd like to welcome Giora Engel, co-founder and CEO of Neosec. So Giora is here today to talk to us about next-gen API security. Giora, super excited to have you today and dive into this topic with you. Would love to start off talking a little bit about kind of your background and how you got into this space.
Thanks, Kaitlyn, for having me today. So my background actually starts, more on a nation state level, more on the offensive side. But about 10 years ago, I started another company called Light Cyber, which invented what's known today as XDR, a combination of network and endpoint security with behavioral analytics. And over the years, we noticed that everything moved to the application side. Everybody was building APIs and applications, while the enterprise network was becoming less and less of the center. So that's what kind of brought us to that space of API security.
So let's dive in kind of to this main topic here, and I would love to start off talking about what are the main challenges in security that you're seeing today.
So I think that the main challenge is that everything changed so rapidly from a world where there were data centers and business systems that were kind of concentrated inside all these gates, and there was a very gated access through VPNs, and it was like a whole fortress type of thing. Today, the way that companies build their APIs and their applications, they have to be exposed to the outside because they need to complete some kind of business process. They need to expose some stuff to their customers and so on. So with that, the security challenges are very different. They need to protect these applications and APIs that are by design exposed to the outside. They expose all these sensitive things to the outside, and they're kind of starting from scratch in that new space.
Absolutely. You touched on it, but with this rise of microservices and this proliferation of APIs, security's really become top of mind for everyone right now. In terms of APIs specifically, what kind of abuse could happen on an API, and how would someone potentially exploit it?
Yeah, so we see three main challenges with APIs when it comes to that particular aspect. One of them is typically you need to actually have a good inventory and good understanding of of your complete API space in order to have a good plan of protecting it. So I mean, it sounds very, very trivial, but it's actually not trivial. Most companies, they have so many different developer teams and so many different APIs and instances of the gateways and so on. So getting a good inventory continuously is one challenge. Now, with APIs, after they're in production, there are two main challenges. One of them is vulnerabilities. There are always different types of misconfigurations, vulnerabilities in the code, and different types of deployment issues that can cause an API to be more sensitive or more prone to attacks. Then, even if your APIs are completely perfect, let's say you didn't make any mistake, your APIs can still be abused because what happens if your end client or B2B partner gets compromised or makes a mistake? Then somebody could be an attacker, could be an error in the code, accesses your core business and manipulates data and so on. So API abuse is also a huge problem, and we see it in action in many different attacks that we hear about today.
Are there any kind of real world examples of how this has actually happened to an organization that you could walk us through?
I think one of them that probably everybody knows about is Facebook and Cambridge Analytica. I think this is a clear case where there were some APIs that were designed to expose data to the outside and be used by B2B partners that pay for that data. But if it was systematically used in a way that is not, that is kind of not consistent with how Facebook likes to do business, it can actually cause a lot of damage. So that was one good example that the APIs were actually used as designed, but in the grand scheme of things, it was not a good thing. It was overused. It was used to create fake content and so on and so forth. So this is kind of big examples that everybody knows about. But small examples happen every day for almost, I would say, every company that exposes APIs. Give you examples from the payment space. when you're a payment provider, you have a lot of merchants connecting to your platform in order to transact. All these, there could be thousands and thousands of merchants. Some of them can be compromised. Compromised merchants access your APIs, have access to PII of end customers and so on. So that is an example that I'm going to demonstrate later today. That is kind of inherent in the APIs. Of course, some of your clients can be compromised. Healthcare today is required to actually expose everything through APIs. But what happened if what happens if somebody's compromising the credentials, especially if it happens between pairs or between big infrastructures. So these are the areas where we see a lot of things happening, and I think today about maybe 50% of attacks are around APIs. It started from almost zero because nothing was exposed that way 10 years ago, but really in the last few years, we see that the majority of attacks is happening through APIs because that's the most direct way of attackers to get to the data and manipulate the data.
Yeah, definitely. That makes a lot of sense. So, we've talked about things are changing. There's these new vulnerabilities and things you have to think about. Why is a new approach to API security needed specifically?
So the reason why we need a new approach is that when before APIs were so popular, people built web applications, and web applications today are also built on top of APIs, but they I think they make only part of the assets that are exposed to the outside. I think for web applications you can always try to step up authentication, and there are all sorts of tricks to make sure that you're actually working with the right person. But with when you expose more and more APIs, it's much harder to actually know what's going on. And all these approaches that use signatures and known attacks and kind of assume that you have a WordPress site or behind it and so on are just not relevant anymore. When you deal with authenticated access through APIs, all these signatures are not working, and instead you need some kind of behavioral approach that understands what the client or user is trying to do, and whether or not it's actually a good idea. Because that authorized traffic is that that looks like normal API calls is the most sensitive because it can actually access the data and manipulate the records. So behavior is really the key here, understanding the context and what's behind that traffic.
And the title specifically of our conversation today is Next Gen API Security. So I'm really curious in particular, kind of what that means and how the Neosec approach in particular is different.
So in Neosec, we focus a lot on that behavioral aspect. It's the main focus is on authenticated traffic, all these B2B APIs or any other APIs. It actually can be any flavor and any kind. But we see a lot of these authenticated APIs that carry that the sensitive details. Now for us, it's really important to focus on the client. We see the APIs from the server's perspective because we protect the provider of the APIs. But we need to kind of transform our point of view to see the client behavior and understand what's their normal behavior versus what they're trying to do right now. And that's the key of kind of the core of behavioral analytics. When you understand the normal behavior, then you can easily find deviations that by themselves may look like normal API calls, but they're done in a way that is not normal for that user or for that application. And that can indicate some kind of compromise or problem in the implementation or some kind of bad use of the APIs. So that's one aspect that we're kind of very unique in, and I'll show in a few minutes. And the other thing is that we're 100% SaaS and very very data centric. So with our platform, you can always go back to the data and see what happened, investigate, threat hunt. All these things that that basically enable you to go back to the data and feel it in your hands. At the end of the day, I think as developers and also as security practitioners, just getting some kind of report with alerts is not enough. We need to go back and see what actually happened. So that these are kind of two differentiators on our side.
Yeah, absolutely. And this of course is incredibly important to us here at Kong as well. So one of the cool things is we recently announced a partnership between Kong and Neosec. Could you talk a little bit about kind of what this partnership means to Kong users, and Neosec as well?
Yeah, so we're very, very excited about this partnership because it's really a truly kind of end-to-end integration that that combines the strength of API management and API gateways, where of course Kong is the leader, and the API security capabilities where Neosec is leading, and in the technical integration it means a few different paths that are really helpful. One, the most basic is the fact that we at Neosec can get metadata about the API calls directly from the Kong platform, using basically the standard logging. That by itself enables us to first to discover all the APIs that go through the gateways, as well as understand behavior, find abnormalities, and so on. But just looking into the traffic that goes through the gateway is not enough, because we all know that the gateways are only implemented on part of the infrastructure. Ideally, we want them to be implemented on more assets. It just takes time and different teams and so on. So with Neosec, you can actually take data also from other parts of your platform or other applications that are not necessarily covered by Kong today, and that enables you to discover and eventually better manage these APIs. So that is the kind of the second input beyond what you have today through Kong. And then the other direction is our ability to respond and prevent different types of attacks using Kong policies. So once we detect some kind of misbehavior, we can automatically create a Kong policy to block or rate limit the user, and that kind of closes the loop and prevents the attack from happening, or prevents the damage from being done.
All right, so I know we've talked a lot. I know you have a demo prepared for us next. We can see some of these concepts in action. Maybe let's switch over to that, and then could you just tell us a little bit about what you're going to be showing the viewers today?
Yeah, so on the demo, we're going to use an example that I mentioned before in the payment space. The concept, of that example is that these are B2B APIs. The payment provider is the author of the APIs. It provides these APIs to many, many different merchants. And again, it can be a lot of different types of payment platforms. It doesn't really matter if it's like a homegrown or some kind of payment vendor. These use cases really repeat themselves, and we're going to show how a compromised merchant can can basically get attacked and have some adverse effects on the payment provider, and how we can detect it and how we can block it using Kong. So with that, I'll switch to the demo, and let's go through a different screen. So what we can see here, I mean, we'll start from the dashboard. We see different alerts based on criticality, also based on different types of data, like PII and other attributes that we generate. We always start with discovery. Discovery is kind of our way of creating the inventory of APIs. So I know this is just a simple example of a few different types of APIs. We have invoicing APIs, we have order-related APIs, we have authentication APIs, and so on. So this is kind of common, right? We have different microservices and different APIs within each one of them. Now, each one of these APIs is discovered automatically. It means that the metadata that we receive is all these access logs that look like all these URIs that are accessed and so on. By analyzing the data, we understand that some parts of the URI are actually parameters, and that's how we parameterize these APIs automatically. So the list here represents the actual API endpoints, not the URLs, because URLs can have millions of URLs. Now, as you can see here on the screen, we also understand the frequency of each parameter, the typical values, and at what value type and so on. We can even show distribution of values and so on. You can see here that that some alerts can be attached to the API, and these alerts mean that there is something about the implementation of the API, such as a vulnerability or deployment issue that might be problematic. So for example, here, no rate limiting means that for some reason there is no practical rate limit on the API. It means that our product can see a spike of requests, and without the error codes that indicate that there is some kind of rate limiting. So this is basically kind of reflects that in actual production traffic, these spikes are not stopped, regardless of what specific configuration you have. Of course, you can remediate it, but by adding the right policy or adding that traffic to be gated by Kong if it's not gated in the first place. Because again, we see that in many cases, only some new APIs are implemented correctly, but there are also a lot of other APIs or other developer teams that didn't get there yet. So this is this typically gives you a very good start on which APIs should get the priority and should be managed properly. Now, if we go to the alerts, as you can see, there are two types of alerts. There are these API alerts, like the rate limiting that I mentioned before, which really focus on some issues with the API or its deployment. But now I wanted to show an example on the user behavior side. So these user behavioral alerts, they kind of start from the same data, but they focus on what the user or client is trying to do. And essentially, the problem with that we're going to show here is not a problem with the API. It's really a problem with how it's used by an authorized user. So let's start with one of these alerts. This is an account takeover alert called abnormal location. That alert says basically that typically that client, and again, this is a merchant client. So it's basically it's an API key. It's a token, auth token that is used by the merchant. And typically that merchant comes from an AWS environment. It means that it's a business to business implementation, service to service. They're AWS based, but all of a sudden it comes from a completely different network. So that that change of implementation is unlikely for production implementation of a merchant based on what we saw on that merchant before, and therefore it's a good telling sign for account takeover. Now the next step, and this is I think where it gets exciting, because just getting the alert is one thing, but being able to investigate and understand it in detail is really where it shines. And I think this is also where security practitioners and developers can collaborate very well, because it kind of speaks the same language that that we're familiar with. So now let's go and investigate. As you can see, we can pivot on a few different entities. Let's go with the merchant. What we can see here is a complete timeline of events. So this is basically the merchant here is the subject. We see a complete timeline of events, everything that happened from that merchant. We keep at least the last 30 days of data, so you can always go back. I mean, you can scroll and go back, and I'll show that you can also query into the data. And we see that normally there are these order transactions, creating an order, creating an invoice, storing an order, authorizing payment. So these are kind of repeating transactions that the merchant creates. But all of a sudden, we see this abnormal location. This is what brought us to here in the first place. We see some abnormal headers also. Typically, the implementation uses Python requests, and all of a sudden, we see a different user agent, Postman. Again, it's a service-to-service implementation. Very unlikely for the user agent to change like that, because it's not a browser. Now, if we look at the actual behavior, we see that that merchant is all of a sudden listing all the invoices with that other API, and everything looks legit, like from a credentials perspective, right? If you look at it in isolation, it's a completely legitimate call. And then retrieving invoices one by one, with different invoice IDs. You see that the invoice ID here changes. So again, you can see exactly what is going on. Each request looks legit, but as we can see here, there is some kind of data scraping. Somebody is decided to take the data of all the invoices out of the system. Maybe in order to to commit some other fraud outside, or do all sorts of other nefarious actions. But these invoices naturally contain PII information and so on. So it's it's an asset that you don't want to lose. But again, what happens if your client gets compromised? You don't have control over that. So now you have control, because that bad behavior can be detected. That data scraping can be detected based on profiling the normal behavior. That account takeover that we detected in the beginning can also be detected by observing normal patterns of connectivity between the B2B client and between our system. Now, as a next step, I mean, just to show that you can do beyond just investigating the specific alert, you can also go ahead and query for other occurrences. So let's say now we're interested to see if that pattern of listing all the invoices followed by retrieving invoices, if that is a common pattern. Does that happen elsewhere? Maybe we got attacked by by similar attack scenarios before. So we can actually mark that behavior, and that will help us to pre-populate the query screen. So the query screen is kind of simple. At the end of the day, it basically populates listing of invoices followed by show invoice, followed by show invoice, and so on. If we hit search, we'll see the same occurrence, right? So we found that that same thing that we just saw. But if we want to look for the same pattern elsewhere, we can actually remove the date range. We can remove the specific merchant ID. And all of a sudden, we get other occurrences. Each one of these has its own timeline. These are different merchants. We can actually go back to these merchants and see what happened and why somebody is trying to access multiple invoices like that. So that again shows the the threat hunting capabilities and how you can go beyond just alerts. And in some cases for developers, that's understanding how the system is being used, and that is a good way to understand what's actually happening in production. Now, the last thing that I wanted to show, last but not least, is how we can use Kong as an automated action, as basically as a response action that prevents that type of operation. So if we go to automated actions, you can see that there are different types of actions that you can take here, including Giora tickets and creating different types of automations. But one of the automations that is super important is the Kong integration, and that enables us based on certain conditions. We can, for example, add conditions on data scraping and add more parameters to that condition. We can set up a policy that would automatically communicate with the Kong admin interface, and via the Kong APIs, add a policy dynamically to block a consumer, meaning that that user ID, that client ID, can be immediately blocked once we detect data scraping. Of course, we can add timeout. We can also choose to rate limit and not block. Right? There are a lot of different options here, but the idea is that once we detected something that is problematic and can cause some business disruption or some loss of data, we can create different policies to immediately take action. And we can use it. We can do it via of course the Kong APIs that are aware of the user context and so on. And that's the beauty of that integration. It's not just by IP or by some technical parameters that are not accurate. It can actually be as granular as the user in order to do that blocking. So just to summarize what I showed here, I showed how you can use Kong both as an input of data into behavioral analytics. Kong itself is doing the real-time operations of on the actual API calls. It can terminate the authentication authorization. There are a lot of real-time security features that Kong performs. But when it comes to analytics and understanding the behavior, finding misbehavior and blocking it, this is where Neosec comes to play.
Awesome. Thanks, Giora, for the fantastic demo. It's really helpful just to see how this all comes together. So for our listeners, if you are interested in learning more or trying this out for yourself in particular, we will have some links for you in the description. So you can head over to neosec.com and try this out with the free trial. We will also drop the Kong Gateway free trial if you're interested kind of in seeing how the integration works as well. So Giora, any final thoughts you want to share before we wrap up?
Yeah, first, I think again we're very excited about this partnership. I think we by combining the two products together, you can achieve a much bigger goal. And as we see today, security is an integral part of any new design of APIs and expansion of APIs. So using the technologies together can really help to achieve that.
Absolutely. Well, thank you again so much for joining me today. And thank you to everyone who's listening in. We will see you all next time.
Thank you.